Honeybees have a harsh caste system. Of the tens of thousands of bees found in a hive, just about all of them are female workers, and they do pretty much everything from cleaning and building the hive to collecting pollen and nectar. Their lives are so intense that while a worker can live from 4 to 9 months during the winter, a worker bee born in the busy summer season will only last about 6 weeks before dying of exhaustion. It's not a whole lot better for the 300 to 3,000 male drones who basically hang around waiting to mate with a queen during the summer, after which they die, or are kicked out of the hive when fall comes and they are of no more use. Then there's that queen. There's one per hive, and she can live to be up to 5 years old, laying up to 2,000 eggs in a day. And she owes her entire existence to a bitter, protein-rich secretion called royal jelly. Given their long life and unique position, there's rarely a need for a new queen, but when one dies or leaves the hive along with a swarm, the colony needs to find a replacement, and fast. In both situations, a larval bee is chosen to become the new queen. The science of how and why this happens isn't entirely settled, but one thing is certain: royal jelly plays a large role. Worker bees produce royal jelly from a gland in their heads called the hypopharynx and feed it to newly hatched honeybee larvae. The milky, yellowish substance is made of digested pollen and either honey or nectar. Not only is it high in protein, but royal jelly also has a combination of vitamins, especially vitamin B, plus lipids, sugars, hormones, and minerals including potassium, magnesium, calcium, and iron. This bee superfood also contains acetylcholine, a neurotransmitter also found in humans. It's what nerves use to tell muscles to start or stop movement, and may also contribute to learning. All those nutrients might explain why royal jelly is often marketed as an expensive dietary supplement cure-all, even though studies haven't been able to prove that it does anything too significant for humans. We are, after all, not bees. But for bees, it does a lot, and around day 3 of the royal jelly diet is where things get interesting. Worker bees will choose a few of the larvae and continue to feed them royal jelly, while every other larva is switched to a less nutrient-intensive diet of honey, pollen, and water. As the future queens gorge, the royal jelly triggers other phases of development that workers don't experience, like the formation of ovaries for laying eggs. If one queen emerges first, she will search for and destroy any other queen still developing in their wax cells, and if multiple queens come out simultaneously, they will fight to the death until only one queen remains. Now, we don't know exactly how the worker bees decide which larvae get the royal treatment, but for a long time we thought it was random. That would make sense, because basically worker bees and queen bees are genetically identical. But there's some evidence that the selection of a queen might not actually be so random. A 2011 study found that the larvae of future queens have higher levels of proteins that increase some metabolic activities, so there may indeed be a tiny genetic difference in the two that plays a huge role. Scientists are also still trying to figure out what it is about the royal jelly that lets it change a larva's whole life. For a while we thought it might be a hormone in the jelly or the way it affected insulin signals in the larvae. Then another 2011 study zeroed in on a protein called royal actin, which, when isolated and combined with other nutrients, can transform larvae into queens, just like royal jelly. Once they emerge, queens continue eating royal jelly their entire lives, and given that the queen lives a lot longer than the thousands of relatives around her, it sounds like a reasonable dietary choice for a royal bee to make.